This is problem number 4 from section 9.3. In this problem, they want us to solve the given system of equations. And they give us 3 different equations with 3 variables. Again, we have choices between graphing, substitution, elimination, matrices. Usually I'm going to use substitution and elimination, kind of interchange them as we go about. I have some steps that we're going to follow to actually solve this problem. And because all of these variables there's no missing variables, I should say, in any of these equations, we're actually going to follow exactly step by step through this. So part 1, cancel a variable in the first and second equations. I'm going to cancel x because it's easiest. X and negative x, right? They're already opposites of each other. So let's cancel x. So we're going to take x minus y minus z equals 2, and negative x plus 2y minus 2z equals negative 7, and we're going to add them together. This gives you 0, this gives you y minus 3z equals 5, or negative 5. Now I'm going to do the same thing with the bottom 2 equations. And I like to number these. I should have numbered this. This is equation 1 and equation 2. And then we're going to take equation 2 and 3. So negative x, and by the way, we're canceling x, right? Same variable. That's what step 2 says. Cancel the same variable in equations 2 and 3. Negative x plus 2y minus 2z equals negative 7. 2x minus y minus 5z equals negative 1. I said I'm canceling, hope I wrote z, I meant x. Canceling x here. So I'm going to cancel x by multiplying the top equation by 2. Should have put that line there, dang it. Jacking it all up. So I got negative 2x plus 4y minus 4z, and then 2 times negative 7 is negative 14. Then I'm going to add, so I can kind of cross this equation out. Then I'm going to add this equation with this equation. So when I add them, to cancel, I get 3y. That's minus, that'd be 9z equals negative 15. Now, anytime I see an equation like this, I'm going to actually, if I can divide out a common number in there, I'm going to do that. So I'm going to divide each of these by 3. So that's y minus 3z equals negative 5. Now, what do you notice here? This equation is the same as this equation. In step 3, they say use the 2 equations you created to solve for one variable. So we're going to go and we're going to take y minus 3z equal to negative 5. And we're going to cancel y minus 3z equal to negative 5. We're going to try and cancel, let's just say cancel y. Now you should see what's happening here. If we cancel y, I got to multiply this equation by negative 1, which gives you negative y plus 3z equals 5. And when I add those, this is 0, this is 0, so 0 equals this is 0. What does that mean? This tells us we have infinite solutions. But this problem is a little different because when we find out that we have infinite solutions, because it's 3 variables, all that really means is one of the variables can be any number, and the other 2 are going to actually have set numbers based on the one variable that we choose to be infinite. So when we have infinite solutions with 2 variables, right, the numbers can both x and y can be infinite. But when we have x, y, and z, only one of these variables is going to have an infinite solution, meaning it can be any number, and the other 2 are going to be based off whatever that number is. you'll see what I'm talking about here. So at the bottom, I'm going to say that z is the variable that can be anything. And then I'm going to find an x and a y that correspond with z. So I pick z to be my infinite variable. And I'm actually going to move this. And we'll write up here, z is the infinite variable. So what I want to do here is I want to write two equations, one for x and one for y, that are in terms of z. So let's go back to this equation right here. I have y minus 3z equal negative 5. I'm going to write y minus 3z equal negative 5. And I want y in terms of z. So what I do is I take this equation, I add 3z over, so that's y equals 3z minus 5. So right here, this is 3z minus 5. So anytime I know z, so let's say z is 1, that would be 3 times 1 minus 5, meaning y would be negative 2. If z is 2, it's 2 times 3, which is 6, minus 5, which is 1. So you can see that this number is based off of what our infinite variable is. And I picked z to be my infinite variable. I could have picked x or y. It doesn't really matter which one you pick, as long as you pick one of the variables to be the infinite variable. Now we're going to look at, do we have an equation that has z and x in it? So I don't see any equations with just z and x. So what I need to do is I need to take two equations. To get just z and x in it, I need to cancel y. So we're going to go up here and we're going to say cancel y. And we're going to pick two equations. I'm going to cancel equations 1 and 3. So x minus y minus z equals 2. And then 2x minus y minus 5z equals negative 1. I'm going to multiply the bottom equation here by negative 1. That's negative 2x plus y plus 5z equals 1. I'm going to cross that out lightly. Add these together. That's negative x. That cancels. That's plus 4z equals 3. I have an equation where I have x and z in it, so I need to write it so x in terms of z. So I'm going to, in order to get that, I'm going to add the x over, so it's 4z equals 3 plus x. Then I'm going to subtract 3, so it's 4z minus 3 equals x. Now, that was y in terms of z. This is x in terms of z. So my front term here, and actually I'm going to rewrite this right here. So my first term is 4z minus 3. My middle term is 3z minus 5. And my last term is z, which is my infinite variable. And so this is my infinite solution, because now both of these are based off of the z variable, and the z variable can be any number. And how did I tell that I needed infinite solutions? When I started to cancel after I combined equations 1 and 2 and equations 2 and 3 together, I noticed the equations were the exact same. So when I cancel them, I got 0 equals 0. Anytime you get 0 equals 0, you know you're going to have infinite solutions. And if you have 3 variables, then you have to go through and you have to write expressions for your y variable and your x variable if you pick z to be your infinite variable.